Hi, good morning. Sorry about the late start. This thing has got me busy this morning. And something I'll be doing, what's today's day? 22nd. So I know what I'm doing. Finally got some video editing software. I'm learning how to use it. About 90% done by next Monday. I hope to get this posted. But I'm going to do this so I know which class it is. How did I know it's the 22nd of February? Coming soon to a computer near you, Dr. White and Ken 1212. I can't believe it took me a week and a half for them. Oh yes, we can do that. At least I got it. All right, we're talking about alcohols and went through some reactions. And just to remind you, yesterday we talked about 3 types of alcohols that we'll be learning about. When you have one R group on the carbon with the hydroxy group, that's a primary alcohol. When you have 2 R groups, and they can be the same or different, that's why we use R and R prime, just like X and Y and NAF, that's a secondary alcohol. And when you have 3 R groups, remember this is part of the semester, you have to know how to count up to 10, and 3 R groups, that's a tertiary alcohol. And it turns out most things in chemistry for all 3 are the same, but there's a key reaction we're going through now where they're different. And yesterday I talked about oxidation of a primary alcohol. We use an oxidizing agent. We use O for oxygen in brackets to say that's an oxidizing agent. And what happens is for primary alcohol, the oxidizing agent removes the hydrogen from the oxygen, hydrogen from the carbon, and forms a carbon-oxygen double bond. I like to write it this way. You could also write it this way. The first way just looks cooler. You'll find out later these are aldehydes, and I've done a lot of work with aldehydes, so I like to write it in the cool way. And we went through this yesterday, but to start off today, I would ask you what's the product or products from the following? 3 points each, then. While you're doing this, you think about the weather outside, global warming. Actually, a single group of temperature is not what global warming is all about. It's about an overall change in the climate of the planet, which is unfortunately, in my mind, happening. Anyways, back to the good stuff. Organics. looks like everybody's done. Let's take a look at this problem. How do you approach it? You look at a molecule and say what's different, what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond, and then oxygen tells you, look at me, I'm different. It's got a hydrogen and a carbon. It's an alcohol. It's a primary alcohol. It's being oxidized. That's what this is. We'll learn later on one of the most important oxidizing agents around, and sometimes not for a good reason, is oxygen in the air around us. And therefore, primary alcohol oxidized gives an aldehyde. What's my R group? This right here. Do you break carbon-carbon single bonds? No. So I have 3 across, these 2. This is the carbon, that's this carbon right here. Becomes a carbonyl carbon. Oh, you don't know what that means yet. I'll teach you in a couple of chapters. Carbon double bond to oxygen. And now I know there are 4 bonds to carbon. And if we look at this carbon here, how come there's only 1 hydrogen? 1, 2, 3. The double bond counts as 2 bonds. 4 minus 3 is 1. And that's how you do it. And that's how you do primary alcohols. Now you can't have a primary alcohol in a ring, because when that happens, it's a secondary alcohol. And let's talk about oxidation of secondary alcohols. Here we have what? A secondary alcohol. How do you know that? 2 R groups on the carbon attached to the hydroxyl group, OE. If I oxidize it, and you'll be doing some of these in a couple of weeks in the lab, so you can have some fun with this, but let's talk about it. What happens, same thing as a primary alcohol, you lose these 2 hydrogens, the hydrogen from the hydroxyl group and 1 hydrogen from the carbon the hydroxyl group is on. You form a carbon-oxygen double bond. And now you'll learn later on in a couple of chapters, this is called the ketone. And Dr. White loves ketones. And aldehydes too, they've been good to me. I've been good to them. Most of my PhD thesis dealt with aldehydes and ketones. So, anyways, we'll talk more about that. Let's do one. Now, there's 2 ways I can write a primary alcohol. Because you have rotation around this carbon-carbon single bond. And I do both, so let's get used to these 2 structures are the same, 2-butanol. I just have this bond going down. We do that in organic chemistry to save space. If we're running out of space, which on this board it will happen, but these are both the same. So if I react this with an oxidizing agent, what do you get? Secondary alcohol. I'll call one of these R prime and the other R. Doesn't matter which one you designate which. What happens? The carbon with the hydroxyl group is now going to be double bonded to oxygen, this oxygen, and what's attached to that carbon is still attached, R and R prime. R is a methyl, and R prime is an ethyl group. Now, if we did it here, same thing. R prime, this would become the carbon double bond to oxygen. R is methyl. R prime is ethyl. These are both the same compound. In one case, I'm sort of showing bond angles. And this is the way most organic chemists do either one. On the board I will, on my tests I will. So I want you to be aware of this and practice with it. why don't you try this one for your fun and enjoyment on this foggy morning, semi-foggy morning. And one of the questions, which I'll talk more about when we get into aldehydes and ketones, why do you want to make an aldehyde or ketone? Well, it turns out they're very important aldehydes and ketones in our daily life. Both organic chemists make them and use them, and Mother Nature does too. We'll learn later on that an important group of molecules, which most of them, not all of them, but most of them, we call hormones or steroids, contain a ketone in them. So if you think your hormones are important, and I think mine are, without it, I wouldn't have this much spirit. I don't know about the hair part, but anyways, ketones are important. The same thing with aldehyde. All right, let's take a look at this. What's different? Ooh, oxygen with a hydrogen and a carbon. And notice it's a secondary alcohol. I'm oxidizing it. I'll lose these two hydrogens, form a carbon-oxygen double bond, and now I can say here's my carbon with the hydroxyl group. What's R and R prime, doesn't matter which you call which. In this case, they're the same. And you know in math you can have X equal to Y, or they can be different. What happens? This carbon is double bonded to oxygen, and what's attached to that carbon, R and R prime, are still there. Oops. And you form that ketone. Now, the nice thing about ketones are that you can have them, unlike an aldehyde, in a ring. I'll do this one. And now take a look at this, because this confuses students sometimes, but if you look carefully, you'll see it's not really that bad. And that is, what's this? Well, I've got a ring, but that's just carbon-carbon single bonds and hydrogen there. But oxygen, hydrogen, and a carbon right here. It's got a hydrogen. It's got carbons here. It's got carbons here. It's a secondary alcohol. And what happens when you oxidize a secondary alcohol? You remove the two hydrogens and form a carbon oxygen double bond and get what you'll learn later on as a ketone. So what happens here, you don't show the hydrogen there, but I'll lose that, I'll lose that. Here's the carbon right here. Do I break the ring? No. This carbon will now be double bond to oxygen. We show it this way, and that's a ketone in the ring. And it looks like I'm smiling and having a good time. I am, because I've done a lot of work with ketones that are in the ring, and I really like them. Isn't that pretty? I'll let you try this one. Is you a nice person in it? Yeah, I'll get toward this way. I'm learning names. I think I'm up about 85.7%. By test 2, that will be 100. And even I'm getting some of the pronunciation slowly, painfully, but I'm getting there. right, let's take a look at this. And you already know what I'm going to say next. Yeah, you're right. What's different? Oxygen with a hydrogen and a carbon, alcohol. What kind of alcohol? I need to know because I'm oxidizing it. And so secondary alcohol, oxidize it, remove the two hydrogens, form a carbon-oxygen double bond, and whatever is attached to that carbon with the hydroxyl group stays there. And that's my carbon right there. Now you could say this is R prime and this is R. You don't have to designate it, but it shows you the relationship. You break carbon-carbon single bonds? No. This is a carbon right here with the hydroxyl group. It will be this carbon right here that's double bonded to oxygen, and you get that really nice ketone. Now, as I said yesterday, or the day before, I think both days, on test 2, I won't have one, but I'll have 2 or 3, probably 3 synthesis problems. And I'm going to let you try this one on your own, see if you can do it. What would be the starting material for the following reaction? All right, looks like everybody's done. If not, I'll give you 3.57 seconds. 0.2, 0.3, 0.5, 0.57. All right, time's up. I think it's evolving into Awful Humor Wednesday. All right, what do we have that's different? Oxygen, double bond to carbon. It's got carbons here, carbons here. I'll call that R and R prime. What do you oxidize to make, you'll learn later on, this is called a ketone. A secondary alcohol. What's my R group? And you can call it either one, doesn't matter. I'm going to call that R, and I'll call these 3 carbons R prime. So I have my carbon with the hydroxyl group, which is this carbon. I have attached to it R, methyl, and my R prime 3 carbons. Notice if I end up with 1, 2, 3, 4, 5 carbons, and I'm not adding any carbons, I better start with 1, 2, 3, 4, 5 carbons. And I did. And that's how you do it. Now, if you notice, for both primary and secondary alcohols, you need a hydrogen on the carbon with the hydroxyl group because you remove it to form a carbon-oxygen double bond. Here I have a tertiary alcohol. And notice on the carbon with the hydroxyl group, there's no hydrogen. So if I try and oxidize this, what will happen? Nothing. Now, as you see on this slide, tertiary alcohols cannot be oxidized. Now, I've said this a couple of times. I teach by my golden rule of teaching, which is I don't do to my students what I didn't like done to me when I was a student. And yes, a long time ago in a galaxy far, far away, I was a student. But anyways, what I hated, I mean hated when I was a student in organic chemistry or any chemistry, instructor puts down give the product or products, and the answer is no reaction. No, you asked me to give the product or products, why'd you put that down if the answer is no reaction? That's not right. Therefore, on my test, I'll never have this reaction because I'll never have on any of my tests the correct answer for give the product or products being no reaction. If I ask you, what does it make? It's going to make something. Now, unfortunately, the people who write the ACS final don't believe in that. I'll remind you to remember this could be a correct answer there, but on my test, no. This will never be a correct answer. If you put down no reaction, I will bet all the money in my wallet, and I only bet when I know I've won, that you've lost, you have put the wrong answer down. All right, let's talk about some other types of alcohols that are in our daily life. And this is where you can have an alcohol with more than one hydroxyl group on it. We'll learn later on that's also called polyol. Poly means many, OL ending for an alcohol. So that's why we call them polyols. And the first one is glycol. And I'm going to only ask you to learn, these are common names. And there's only one glycol I'd like you to be aware of, and that's the simplest glycol, or alcohol with more than one hydroxyl group. When you have two carbons, and each one has a hydroxyl group, this has a common name. This is not the IUPAC name, and I'm not going to ask you to learn the common name, called ethylene glycol. The IUPAC name would be, let's see, ethane 1,2-diol, di meaning two alcohols, OL, and which carbons are they on, 1 and 2, but nobody calls it that. This is ethylene glycol. It turns out this is a poisonous substance, but all of you use it. What? I don't know if I use a poison. Well, you mix 50% of this, approximately 50% of water, and you have antifreeze. That's what's the antifreeze in your car radiator or your neighbor's, your parents', whoever's car out there in the parking lot that has a radiator. And therefore, this is what we use. Why do they use that? Because a combination of water and ethylene glycol causes a colligative effect. Yeah, you learned about that. It lowers the melting point, which means water alone, which would freeze at 0 degrees C, 32F, and you don't want that ever happening in the radiator, would be bad. By mixing it together, it freezes a lot lower. I'm not sure what it is. Same thing, which I didn't mention, but it's true of the colligative effect. You also have a boiling point elevation. The boiling point is much higher. And that's a good thing with summers in Chicagoland, because this mixed with water, antifreeze, has a much higher boiling point than water, which boils at 100 degrees C, and you don't want your radiator liquid in there to start boiling, because it will expand and burst your radiator, which is not a good thing. Unfortunately, that's a poison. A couple years ago, and I sure hope they found the sick individual, someone in this area was putting out little trays or something of antifreeze, and the animals would come and drink it thinking it's water, and it killed them. And I hope they found that person. All right, on a more pleasant note, let's go to the next molecule with more than one hydroxyl group. and that's glycerin. And that's the common name. The IUPAC name would be, let's say, propane 1,2,3 triol, trimethylene 3-OL alcohol. But this is glycerin. You've all used this in the lab. Remember that thick viscous liquid you put on the thermometer so you can get it in? Anyways, this is used for many things. One is you see a lubricant. The other thing is, because of all the hydroxyl groups, it can hydrogen bond to water. In other words, keep water in it. And it's one of the molecules that's used as what's called humectant. Humectant is something that keeps things from drying out. What is something that dries out? It's lost its water. And where do you want that to happen? Unfortunately, one place is cigarettes. If you've ever smoked a dry cigarette, they're not as good as fresher ones. And I used to smoke long ago. I was addicted to it. It's been many, many decades since I've given it up. But I was so addicted. This is back when you could smoke on planes. I knew how many cigarettes I had to have in my shirt pocket in the package to go from O'Hare to major cities throughout the world. I still remember Detroit was 2 cigarettes. New York, actually Newark, was 8 to 10 cigarettes. LAX, Los Angeles was about a half a pack, 10 to 12. Let's see, Amsterdam was 2 packs. Heathrow was a pack and a half. Why do I remember that car? Now, the other place you'll see this, a better humectant is a number of years ago, and now more than one company makes it. You have those super moist cookies that taste like they're so moist like they came out of the oven. And what do? Well, they put in the humectant, this alcohol, polyol, or alcohol with more than one hydrox group or another one, and that keeps the moisture and it keeps it nice and soft as opposed to getting crunchy. Now, another alcohol which you're not, well, I talked about a little, but let's put a structure up on the board. And don't try and copy this down, but if you notice, well, how many hydroxyl groups are there? Lots. And each one of these is an alcohol. So this is a molecule with more than one alcohol, and you use this molecule most of you in your daily life. The common name is called sucrose. The really common name is this sugar, or table sugar. And table sugar, next time you use it, think about it, you're putting something into your food usually. That's where you're using it, and I'll show you some other uses, non-food related, later in the semester. In fact, one of those non-food related things you're sitting on right now, the cushion in your chair, is made from sucrose or other molecules with more than one hydroxyl group. As I told you, my world of organic chemistry is your world. You just don't know about it. You're actually sitting on it. But anyways, this is, again, sucrose or table sugar, and notice it has a lot of hydroxyl. And the last one I'll talk about this molecule, which is missing a hydrogen, is called vinyl alcohol. That's a common name. If you connect a bunch of them together like you would boxcars in a train, I think you've all seen freight trains, you know, you get stuck at an intersection with a like 5-minute freight train. We put them together, and I'll teach you more about this later in the semester. It's called a polymer. And you have this repeating unit like boxcars in a freight train, and N is on the order of about 1 million. We're talking a big molecule. And this is called polyvinyl alcohol. And you all have that, probably most of you in your home. I don't have any polyvinyl alcohol. Yes, you do. You take that molecule, you mix it with some water, get this white material you buy in a bottle. We call that Elmer's glue. And I worked for Borden. About the time they sold Elmer's glue to someone else, Borden Chemical. And originally glue came from animals, but then later on they found this molecule which can hydrogen bond to things, the alcohol, which is how glues work, sticking different things together. And this is all different alcohols with more than one hydroxyl group in your home. All right, I'm going to turn the switch to off, but I still would like to talk about this. And I think you've all heard in the last number of years, there have been a lot of reports in the news about how researchers have found this molecule or this substance or product has what's known as antioxidants, and antioxidants are good for you. I believe that. And once in a while you hear, well, if you drink a lot of red wine, that's good for you, or dark chocolate, or other things that contain antioxidants. And these are molecules that interact with something. Now it turns out the oxygen we breathe is good for us, it keeps us alive, but it also does other things. And it can oxidize molecules. And I'll write it this way, oxidize, to make what's called radicals. They're usually things with double bonds. And you break it and you have an electron free. And these are called radicals. And they're very, very reactive. Well, if you start breaking down certain things in your body, because of the oxygen that has double bonds in your body does have that, you now have these radicals. They go attack other things they normally wouldn't attack and start destroying things. And there's been stories, and again, this is way outside my level of expertise because I'm an organic chemist, not a medical doctor, where they are finding or saying that many things in our body that go wrong, a number of them could be due to radicals that are formed in your body. And antioxidants have a way of interacting with radicals to neutralize them, not in a chemical sense, but to make compounds that don't react with other things and don't destroy things. And these are antioxidants. They stop oxidation. And most of the good things you see in foods or other things that are antioxidants are phenolic compounds. Now, phenol is a benzene ring with a hydroxyl group, and phenolic means molecules with a benzene ring and a hydroxyl group and other things. And two of the common that used to be until organic chemists found something to help them out were BHA and BHT, which is the acronym for butylated hydroxyanisole and butylated hydroxytoluene. Again, switches in the off position. Here's butylated hydroxytoluene. Notice you've got a benzene ring with a hydroxyl group, phenol, methyl group, and notice two T-butyl groups. That's one of the reasons I love T-butyl groups, because they help keep my potato chips for a long time fresh. You know, if you open up your bag of potato chips, and after a long time, you know how it has that real rancid taste to it if it's been sitting around too long? That's because the oxygen attacks the oil in there and breaks down to stuff that doesn't taste good or smell good. This is one of the things that stop that, and it let potato chips have a longer shelf life. They now found that when they package it with special new packaging material, put nitrogen there, keep the oxygen out, it has a longer shelf life. And for a number of years I tried to convince my mother, and she never bought it. Mom, you should let me eat potato chips because they have important antioxidants in it, and that's healthy for you. She didn't buy that. But that's one of the reasons I like T-butyl groups. All right, That's everything. I'm going to talk about alcohols. I'm turning the switch back on. Quick. And now, unfortunately, how are we doing time-wise? Looking good. I'm going to have to talk about something that really, really stinks. I mean, this is really stinky stuff I'm going to talk about. And that's thiols. And thiols, if you think about what we've been talking about, alcohol. And if you notice, what is an alcohol? Carbon with a hydroxyl group. And if we come over to the periodic table, which I just happen to have here, I have oxygen, and right underneath it in the same column, which we call family, is sulfur. And oxygen and sulfur have some similar chemistry, not all, but some. Therefore, what if I replace the oxygen with a sulfur? And you can. And alcohols have an OL ending. In chemistry, we use THI, thi, to show sulfur. So sulfur, alcohol-like, thiol. Now before that, when I was learning this, this had the name mercaptan. And once in a while, it's going to slip out, and I'll use that terminology, but I try and be good about it. And I'll use mercaptan. And they stink. Now, they have the same nomenclature as alcohols, which I will not have on the test. Thiol nomenclature, my little gift to you this morning. No thiol nomenclature, but that's how you name them. And we need to talk about them. Where do you find thiols? I'm going to skip the first one and go to this one. The odor of garlic and onions, which I like garlic and onions. I hope you do too. They really are nice in cooking. What you're smelling are thiols. Now, another thing that really stinks, and I'll come back to this top one, but let me go to the next slide. Well, hold on, everybody's writing this down. I'll come back to this, trust me. What's the most stinkiest thing you can think of? The defensive weapon of a skunk. Have you ever been by where a skunk let loose at an animal or whatever person? Well, I have never been skunked, but I've been around where an animal's been skunked, and it stinks. And someone did research, and you don't have to write this down, that 45% of the defensive weapon a skunk sprays at something, the liquid that stinks, is this thiol, carbon with a sulfur with a hydrogen, like an alcohol. It's also got a double bond in it. 25% is this, again, thiol, which has about 25%, and I assume the rest is water, maybe a few other smaller isomers, and you know skunks stink. Now, it turns out using that stink is a good thing. And let me come back to the slide. And the switch is full on, so please pay attention. How many of you have ever smelled a gas leak? You can smell it, right? Real easy. Guess what? Methane, which is 99.9% or higher of natural gas, is odorless. What? But I can smell it. You know, what you're smelling is something put in there. And now I have to tell you, unfortunately, a sad story. There are a couple of versions. Unfortunately, the ending is the same. Back in the 1930s, in a small town in Texas, they're having, there's different versions. I like the version they're having a chili social at the high school. It's a fundraiser, something like that. And in the gymnasium next to it, they had a little kitchen where they were making the chili, and there were a lot of people in the gymnasium. And somehow, someone left the stuff, the flame went out, gas leak, filled the whole gymnasium. Someone lit a cigarette, or what you don't know, but I do since I work with, I have worked with hydrogen. Switch right here, go like this. There was a spark inside there. Go like this, another spark. If there was anything explosive here, this would have blown up. And so that somebody could have turned on the light. Well, bottom line, the whole place blew up. About 150 people were killed, and a lot of others were seriously injured, burned. And one of the few times I've ever heard of, the Texas government, state government said, we've got to stop this. And they formed a commission. And the commission came up with an idea, which to this day is still being used. Let's put something in the natural gas that stinks. And what they found was this molecule. This common name is T-butyl thiol. See the T-butyl group. And once in a while I'll use the old name, T-butyl mercaptan. This stuff stinks. I mean stinks bad. How bad? How much they put in natural gas so you can smell it? 1 pound of that for every billion pounds of natural gas. That's stinky. Because you can smell natural gas leak like that. I've smelled it. Or when a flame goes out. In propane, they use a slightly different thiol. You know, your propane tank, so you can smell when that's leaking or the flame went out. And to this day, in America, and I don't know about other places in the world, but I assume they do, they put this thiol in there. True story, when I was a graduate student at Michigan State, and the Michigan State chemistry building is huge. It's bigger than this whole building, and that's just for chemistry. It's like 2 blocks long, 5 stories, a basement, sub-basement, a sub-sub-basement, a penthouse. And it's huge. And one time in late November, fire alarms went out. In the chemistry building, fire alarms go out, you leave. And luckily I was in my lab where I was working by my bench, and ooh, it's winter, grab my coat. And we were all out there, and 10 minutes goes by, the fire department's there, 15, 20, and that's longer than a fire drill, especially cold weather. And someone asked, what's happening? And one of the firemen said, we're looking for a gas leak. And as it happened in that chemistry department, the organic grad students would be together, inorganic, and you were stuck with your own kind, so to speak. And it was either me or someone else that said, what idiot put T-butyl thiol down the sink? And it turned out some idiot in inorganic chemistry didn't know how to properly dispose of it, poured it down the sink, went straight down to the basement. There was a trap, like in there, that was empty. Some of the vapor came out, janitors smelled it, gas leak, and did the right thing, called the fire department. They smelled the gas leak, and finally they figured out what it was. But that's a good use of thiol. And you should know that story because that's keeping you safe from gas leaks. So if your water heater goes out, or your the flame under your pot of whatever you're cooking in your kitchen goes out and is leaking gas, you can smell it quickly and shut it off and get out of that place for your own safety. All right, it's new functional group time. We're moving along quickly now. New functional group. Ooh, I got 2 minutes to go. So. Alcohol. Now, what if I take this hydrogen and replace it with carbons? We have what's known as an ether. An ether is an oxygen that has 2 R groups on it. And they can be R and R prime, just like X and Y. They can be the same or different. We call that an ether. Now, time for another small little gift from Dr. White. I'm not going to ask you to learn the IUPAC nomenclature for ethers. There is, I know them. But I will ask you to learn the common names. And the common names is very simple. You look at an ether, you look at each R group, you name it as an alkyl group, and you add the word ether. So if we look at this molecule, the first question is, what functional group do you see? While everybody's copying down the slide, I'll take a drink of water. All right, if we look at this, what's different, what's not carbon, what's not hydrogen? Ooh, an oxygen. And it's got carbons here, I'll call that R prime or R, doesn't matter. Carbons on this side, R, it's an ether. How do you name it? Well, use your magic chemistry or organic chemistry hand and say, what alkyl group do you see there? CH3 methyl. What alkyl group do you see there? 2 carbons. Ethyl. Now, since this is common names, there's no rule which goes first or second. You can do either one. I'll do it this way. I can do it the other way. It's an ether, and R and R prime are methyl and ethyl. And I'm going to let you out a whole 30 seconds early. That adds up on the sheet. Those of you who have lab tomorrow, don't forget, you need to wear a long sleeve top or a lab coat. If you're not properly dressed, including that, I will not let you in the lab. Don't forget to bring your tools and the lab that's due tomorrow.